Let's look at value returning methods. We'll use the concept of right triangles and the two legs of a right triangle. Just with that information, we can find the hypotenuse, perimeter, and area for a right triangle. Got some stuff already taken care of here. If we put two positive numbers in, that's okay. No error messages come up. If we put a negative value in, we'll get an error message. And if we try non-numeric data, there's a try-catch already in the code that addresses that problem. Our goals in this program are to learn how to write and activate value returning methods and learn how to document those methods. We'll actually check out that third concept, keeping forms the same size, in another video. Looking inside the calculate button click event, got several variables declared, leg 1 and leg 2. That information will come out of the text box. We will use some methods to determine the hypotenuse, area, and perimeter, and a leg comparison to figure out if leg 1 or leg 2, which one is longer or if they are the same. Getting the values out of the text boxes there and check to make sure they're both greater than 0. And we've got a lot of empty spots here that we're not really going to do the math here. We're going to write some methods and have them do the work for us. It'll make it very easy to read up there. Got some methods already written, including this clear results void method, because when you change the text for two text boxes, plus when you hit the reset button, there are 4 lines of code that have to be run every time. No sense copying and pasting those same 4 lines. Have them in one method. Also display output. Got that all ready to go and formatted. All right. You notice we use the word double here instead of void. That means we're going to return a double. Call this calculate hypotenuse because the idea is to calculate the hypotenuse. And I'll send it. I'll have 2 parameters, A and B, kind of like A, B, and C in a right triangle. And I'll declare a variable. I'll call it HYP. I could call it answer, result, or I could call it hypotenuse. And that's the value we're going to return. We'll use Pythagorean theorem, a squared plus b squared, and then we need, well, c squared equals a squared plus b squared, so c is the square root of that. I'll put it in parentheses and put math.sqrt. By the way, that square root method is a value returning method also. Put in something numeric and it gives us the square root. And we'll return HYP, short for hypotenuse here. I'm going to document this brace so I'm aware of what it ends. There's lots of braces all over the place in this program now. So this method will do the work to calculate the hypotenuse of a right triangle if we know the 2 legs. So I'll make my variable back up here in the calculate click event. I'll equal the method that we've just created, and I'll send it the values leg 1 and leg 2 that came out of the text box. And now I'll display it. Remember, there's a void method I quickly showed you down at the bottom. It's expecting 4 arguments. In the HYP place, I'll send hypotenuse. In the AR place, area, and then perimeter, and then leg comparison. But we got a red squiggle here. I didn't make leg comparison have an initial value, so I'll set it equal to null, nothingness right there, and that will make Visual C# a lot happier. Let's test it out using some classic Pythagorean triples like 3, 4, 5. There it is. 3 squared plus 4 squared is 5 squared. Another famous triple is 5, 12, 13. There it is. Also 7, 24, and 25 as another famous Pythagorean triple. A squared plus b squared equals c squared. We also are going to calculate the perimeter. Now, notice that before I get to that, I've got to put some documentation before or inside a method. In a previous video, I put it inside the method. Today, I'll put it outside the method. And we can use the double slashes for each line, or use this multi-line documentation with the slash and an asterisk and ending with an asterisk and a slash. And I'll just put a bunch of stuff in here explaining what the method does. It's going to return the hypotenuse of a right triangle when given the 2 legs. And I'll explain what the parameters are, A and B. Now we're ready to next do the calculate perimeter. It will also return a double. So again, private, and then if it's going to return a data type, what that is, it's double. If it doesn't return a data type, it's void. But this is going to return a double, and it'll calculate the perimeter of any triangle, so I'll go with side 1, side 2, and side 3. It really doesn't matter which one of the 3 sides is a leg or hypotenuse. It actually doesn't matter if it's even a right triangle. A big advantage of this method is that we can copy and paste this into any other program dealing with triangles, and it can calculate the perimeter there as well. Well, I'll declare answer as my value to return. I'll make sure it's a double because we're supposed to return a double. That's why the name of this method is got a red squiggle underneath it, because we have not fulfilled our promise to return a double yet. I'll have answer equals side 1 plus side 2 plus side 3 because that's how you find the perimeter of a triangle. And then we'll return answer. That will make the red squiggle go away because we fulfilled our promise. We said we were going to return a double, and now we are returning a double. So I'll head back up to the button calculate click event, and I'll have the perimeter equal the result of this method. We'll call the calculate perimeter method and send it leg 1, leg 2, and hypotenuse. And again, truthfully, for this method, it doesn't matter what order they go. And it actually doesn't even matter if it's a right triangle or not. Let's test it. We'll type in 3 and 4, and 3, 4, 5. When you add those up, you do get 12 for perimeter. 7 and 24, the hypotenuse is 25. Add up all the sides, you get 56. Things are looking good. Next, we need to calculate the area. Had to fix the documentation there. Area of a right triangle is 1/2 base times height. I'll go ahead and document these ending braces on calculate perimeter. But now, private double, because again I'm going to return, or we're going to return a double when we calculate the area. And we'll need to know both legs. I'll call it leg A and leg B. They're both going to be doubles coming in. And I'll start doing some documentation here above it, explaining what this method is going to do, which is to calculate the area. But you know, it really only calculates the area of a right triangle. I probably should change the name of this method to, instead of calculate area, calculate right triangle area, which also makes it very obvious to me that I can copy and paste this into any other program where I know the two legs of a right triangle. We can just use this method there, never have to write it ever again for the rest of our lives. Just simply copy and paste it. I'll declare double answer. It could be result, it could be area. Remember, the variable down here, if you call it area, knows nothing about a variable called area anywhere else because this is private. I'll just call it answer this time, and it's going to be the area of a right triangle, which is 1/2 base times height. I'll use 0.5 for the 1/2, and leg A, leg B, it doesn't really matter which one is the base and which one is the height. You remember that from your geometry days. And then we can return answer, which will fulfill our promise that we're going to return a double. It says private double. We have to return a double. We said we would, got to come through, and we have. Well, we can test it out. And again, notice how easy it is to read this code inside the calculate click event. So our area is going to equal calculate right triangle area, and we'll send it leg 1 and leg 2. And that method will do all the work for us. We go with 3 and 4. 1/2 of 3 times 4 is 6. We go with 5 and 12. We know the other two are correct. And 5 times 12 is 60. Times 0.5, or 1/2, is 30. Looking pretty good. If we go with 30 and 40, half of that is 600. It does show that probably should make these labels bigger because we're starting to run out of room. Not getting 2 decimal places on all of them right now. I didn't put enough space in there. Now we're going to compare the two legs to see if they are equal or if one leg is longer than the other. That's going to be a string. We're going to return a string that tells us that answer. It's going to be a response, kind of like a sentence. So private string, and I'll call it compare legs. I'll come back and capitalize the C later. That's not really a big deal. We're still going to send it 2 doubles. I'll call it leg 1 and leg 2, and I'll actually write out the words 1 and 2 this time. But remember, you can send a method doubles and return a string. We could send it booleans and return an integer. And again, the idea here is that we're going to take the 2 legs, leg 1 and leg 2, and compare them to see which one is longer, or if they're equal. So I'll declare a variable. This time it's going to be a string because we promised we were going to return a string. I'll call it string result. You could call it whatever you want. And it's going to be a statement about which leg is longer or if they are the same. So I'll need an if block. First, I'll check out to see if they are the same. And if leg 1 is the same as leg 2, then I'll have result equal a statement that says that. Else if, well, let's see maybe if leg 1 is greater than leg 2. Then we'll have to have a statement that says that same thing. So result will be leg 1 is longer than leg 2. I mess up the next one, I won't discover it until I run the program. I end with an else because there's only one other possibility. And I should say that leg 2 is longer than leg 1, but I typed in leg 2 is longer than leg 2. We'll catch that later on. And we're going to return result. And it should be one of those three things. I'll go up and indicate that that's the purpose of this block, is to compare the legs. And we'll test it out. And capitalize the C before we make the trip up there. Again, notice how easy it is to read this BTN calculate click event. So leg comparison is going to equal compare legs. And we'll send it leg 1 and leg 2. In this case, the order really does matter. And I will quickly discover the mistake that I made. We'll go with 3, 4, 5, which means leg 2 is the longer leg, but it says leg 2 is longer than leg 2. Got to go fix that. Leg 2 is longer than leg 1. There. Now we'll try it again. So with 3 and 4, there's all our good math, and leg 2 is longer than leg 1. If we make leg 1 12 and leg 2 7, then leg 1 is longer than leg 2. If we make them both the same, that's a 45, 45, 90 triangle. Oh, the ampersand didn't show up. Well, we're going to need to go in there and put a double ampersand so that we can get an ampersand to actually show up. There. Let's try that. And leg 1 and leg 2 are indicated to be the same length. If you take a moment to scroll through all these methods that you've written, you'll notice that none of them refer directly to anything on the form at all. That's what's really excellent about really good methods like this, is that we can copy and paste them into other programs because they're not attached to anything on the form. And also we have some good documentation to help us out as well.